Hello and welcome to creating orthographic views. Creating orthographic views is the first step into taking a 3D object and representing that in a 2D space or 2D format, which in our case might be an engineering drawing. So we have a few objectives. One is to be able to generate a 3 orthographic view arrangement from a 3D object. Additionally, we're going to look at really understand the difference between 2D and 3D representations of objects and how those correlate. Also, we'll be looking at the concept of primitive shapes and their features and how these are interpreted in orthographic drawing views. And lastly, I'll be throwing a lot of vocabulary at you, so we're going to cover some definitions. Again, this is a very basic kind of introductory first step in looking at 2D drawings. Okay, the schedule for this presentation will be somewhere around 20 minutes, give or take. And we're going to look at discussing a 2D object versus a 3D object. And we're going to look at that conceptually, mathematically, and visually. Secondly, we'll introduce and discuss drafting vocabulary and definitions. As I mentioned, just understanding what we're talking about will be helpful. And then we're going to define 3 commonly used orthographic views. As a final thing, we're going to do a checkpoint problem and review. We're going to have you analyze and sketch 3 orthographic sample view of a 3D object. And we'll take a look at that. Okay, so I'm going to show you a 3D object, and actually we're going to look at it from an end view. You can see the end view there. And what shape is that? What we have here is a circular shape, and it is denoted in that purple color. If I were to rotate this shape up, we have what we call a cylinder. So thinking about the 2D shape that we have here is basically a 2D primitive shape that we've extruded into a 3D shape, which is a cylinder. This 2D shape has an area. Area of a circle is pi times the radius squared, and the units for that would be inches squared, or square yards, whatever it might be. So that's an area. And as it's extruded, we have the 3D shape. The volume, now we're talking about volume, which is 3 dimensions, would be the area, or the volume is pi r squared times the height. And that might be cubic inches. So you see here I have an object that originally looks like a 2D object extruded. So that's as we go from 3-dimensional to 2-dimensional domain. All right, grab my other object. Here I have what looks like a rectangle. As we rotate around, we realize we have what really is a rectangular solid. And looking at it straight on, or orthographically, we have a rectangle. Length times width is the calculation for that, which would be in square inches. And as I rotate it, we have a thickness or a height. Either way you look at it, a thickness, it has some depth to it. And now we have something that's length times width times the depth, which is a cubic, or inches cubed. And that's our 3D object. So you can see if we look at something straight on, we see a more basic primitive object. If we rotate it, we see our 3D object. So I want to cover a few definitions. Ortho. So ortho really is a Greek definition, meaning something that's straight or true or upright. And the whole idea here is we're making these orthographic views by looking at a 3D object straight on. And then we're making views that are correct, or more or less from a straight on object view that we started with. So think of that though as straight, true, upright, and correct. We're looking at something that's been, like I showed you previously, where you're looking at it straight on, and so you don't see any of the depth. You only see a 2D portion of this 3D object. So an orthographic view is basically a 2D drawing that's used to represent a 3D object. And it turns out there's three orthographic views, top, front, and right, that generally provide enough information to define an object. In some cases, there might be the object might be special or have certain features on it, which we'll talk about, that require more views to really define what does it look like in 3D. We're going to focus in this lecture on three views called front, top, and side. And notice the front view. If I were to take this rectangular solid with a notch in it, and I looked at it straight on, it would look like this kind of C shape with a notch cut out. If I then moved my eyesight over to the side and looked at the side straight on, I would see this basically a rectangle, but it does have a couple lines in it, and we'll be talking about those. And the top, if I were to fly above this object and look at the top straight on, or looking at it very perfectly perpendicular to the top, we would have this rectangle shape. Okay, so something that comes up in these parts, in these objects, are what's called features. A feature is a modification to the base primitive object. So we've looked at circles and rectangles, and we could add features to this base primitive object, primitive shape, and these features make it unique. So as you're doing drawings and working in the future, try to look for the basic shapes that are out there, triangles and circles and rectangles and squares. A lot of times you'll see a base shape and then it's just tweaked and modified with features. That will help you in a drawing. And there are cases where it's completely an organic shape and there is no base primitive shapes in there. So we'll eventually see those as time goes on. Okay, so a part feature or a feature that might be on a part helps define the form or the function. That makes it unique. And we're going to be, as we go forward, we're going to be seeing a lot of different features. That includes fillets, which are little rounds that are on the inside of an edge. Chamfers, notches, holes, counterbores, and the list goes on and on and on. We'll see a few examples today, but we will also, as we go throughout, we'll see examples of all these other features, and they provide function to the part. Visible lines, as we look straight on at the part, we see an outline of the shape, and those are the visible lines. Those are the edges that we can see. Those are the edges that are visible. We also have hidden lines in drafting, and these are lines that you can't see, that are not apparent. If you can imagine a feature that's kind of buried behind something, if you had X-ray vision, maybe you could see through the part, and we would show those as maybe a dotted line, and we'll see an example of those. And the center line, if I have a hole, there's a exact center line that represents the center of that hole. That's maybe where my tool would need to go in order to drill that hole. Okay, there is a Wikipedia list of all these drawing, drafting, abbreviation, and symbols, and it's a pretty exhaustive list of all of these meanings and symbols we're talking about. So for instance, if I went down to, let's see if I can find counterbore. There it is right there. Here's a symbol. You click on that and it's going to tell you, hey, there's a picture of it, of a counterbore. Here's a cross-sectional view of that counterbore, what it looks like in the object, in the 3D object. And you can see that's a feature, and it's going to affect the drawing. It's going to have, we have to deal with the orthographic view and how this, we have to deal with how this counterbore will affect it. So you may want to take a look at this list and start to get to know it a little bit. It is pretty comprehensive. Okay, I have here an object, a 3D object that has some features that I've put into it. So my first question is, what is the base shape of this 3D object? Okay, so hopefully you see that it's basically a rectangle, similar to what we've seen before, but it's been modified, and I've added features into it. So looking at the features, first we see up here in this corner, up here, this feature right along here, we're going to call it a chamfer. Basically it just cuts off that corner. Really handy to even at a corner that might catch on something or to help slide something in. It's nice to have a chamfer. Used a lot. Here we have a notch feature. Maybe something needs to fit in here. I have right here what we call a through hole. This is a hole that's drilled all the way through this 3D object. And at the bottom here, you can see it is in red. I have a round feature. You can see if you look straight on that this surface here is rounded. And I also have a blind hole with a counterbore. Okay, so we're going to take this 3D object and we want to draw it orthographically and make several orthographic views from it. Let's go ahead and establish what we're going to call a front view. So I'm going to go ahead and if the part has writing on it, we would put that upright. If it has some sort of logical sequence to it, we would call something the front view if it has a true front. Sometimes it's arbitrary. So in this case, we're just going to call this view right here, as you're looking straight on into it, the front view. Okay. So I want you to take a moment and pause the video and draw this freehand sketch shape on your piece of paper. Okay, welcome back. So I'm going to go ahead and I'll cut in what your drawing should look like. At this point, we're going to pretend, instead of looking straight on like this, that we're rolling around, and as I rotate, that we're looking straight onto this side. So if I hold this orthographically, we can see what this side looks like. Okay, so angling it correctly. So what I want you to do is attempt to draw this shape, what you see orthographically, looking straight on. As you're looking straight on, there's no depth to this 3D object. There is no depth. All you can see is a top, some piece here, and this counterbore, and then down to the round. So go ahead and pause it and draw that. Okay, I will show you the results at the end. Okay, so I'm at a front view. We're going to look at the top view. So if I were to rotate this down and you were to look at this straight on, you could draw that. And remember, there's no depth to this. So we're going to go ahead and have you draw the shape and add in any edges that you see as part of your shape. So go ahead and we'll have you do that. Go ahead and pause it now. Okay, let's going back to the front view here. What I want you to do here now is, looking at the front view, are there any features that are hidden that you don't see that might be not visible? So I want to remind you of this counterbore in here with the blind hole, and it goes in about an inch. So this hole, there's a hole in here that goes in about an inch. I want you to go draw that as hidden lines. So go ahead and do that now. Okay. Additionally, we have a through hole. If I rotate this to the side, remember in our block we have this hole right here. That hole is a through hole. It goes all the way through the part. So why don't you go ahead and draw that with hidden lines. Okay, so let's take a look at the results of what more or less you should have drawn. Okay, so here's a look at what this 3D object I showed you looks like orthographically. So here we have this front view, and basically it's just, you would just sketch that by drawing a rectangle and then adding in the notch, adding in the chamfer, the hole with the center line feature for the hole, center mark for the hole. And this whole story with the blind hole and the counter bore, we have hidden lines, and you notice they're dotted. And basically we're looking through the part with x-ray vision and seeing the feature outlined in there. So that's what the story is with hidden lines. Otherwise, you cannot see that blind hole with the counter bore in this front view. It's just not visible. And also this round here. So if we take that and we flip it to the side, again, now we're looking at the side view with two-dimensional only. Here's that chamfer, and notice the edge of the chamfer is lined up perfectly with this side view. There's the edge, and here we see that whole edge coming across, and that's something we'd have to draw. Likewise, we have the through hole for the hidden lines for the through hole here. Notice we have a center line that is basically telling us the exact center, the true center of that hole, documenting that. And then here's a view of the more or less the top, or the seeing that counter bore with the blind hole and the center mark for that. And you can see how they're perfectly lined up orthographically, so everything's straight relative to the front view and the side view. It's almost as if we're unfolding all of these sides and flattening them out on a two-dimensional piece of paper. And then our top view up here, we see the feature for the edge for the notch and the edge for the chamfer. And notice it lines up with the actual edge I'm pointing to here on the front view. Anyway, that's pretty much what you need to end up. If you didn't quite get that, go ahead and just run it again and try again. And as you practice, you will continue to improve.